Okay, Federico, take it away.
Okay. So welcome to the third day of Copenhagen Macro Days 2020. This is a conference organized by University of Copenhagen, the Central Bank of Denmark, and the VMACS Virtual Macro Seminar. In this session, we will have Per Krusell presenting Suboptimal Climate Policy, coming from the Institute for International Economic Studies at Stockholm University. And then Jim Stock from Harvard University will provide some commentary and discussion. Please remember our ground rules. If you have questions, use the Q&A function at the bottom of your screen. I will pose the question to the speaker at the end of the talk. And all the presenters will receive all of your questions after the presentation. Do not use the chat, but just the Q&A function. Otherwise, everyone else's audio and video will be muted. With this in hand, I give the word to our speaker, Per Krusell.
Okay, thank you, Federico. I'm honored by the invitation, and it's great to be back in Copenhagen, if only virtually. Can you see my screen?
Now we can see it. Thank you.
Yes, good. So this is a talk that is very closely related to what I gave recently at the European Economics Association. So apologies in advance if you have seen it. The slides are a little bit longer than necessary, not because it's poorly planned, but because in case I get questions, I can sort of go to the relevant page. So it is directed toward you guys macro people, and the question is what to do about climate change. My quick answer to this is that there's no sort of real question mark there. We need to do something. Humans cause warming. Warming can be substantial. There's a little bit of or a lot of disagreement on exactly how much and exactly how much human welfare is affected. So if you want to somehow define the optimal emission path, then it's maybe less clear. But what is clear is that we should limit emissions substantially. And my question now is not that, but it's rather how should we do it? And how in principle is trivial in the sense that we understand that warming is a byproduct of economic activity. And this is a case of, because it's a byproduct, it's a case of a so-called pure externalities, basic textbook stuff in public economics. It was Pigou who figured out 100 years ago what to do. And you should just generally, whenever you have externalities, you should apply a tax or a transfer equal to the marginal, in this case, damage externality that the polluter is not paying for in the marketplace. So just help markets correct with proper pricing. And here I think there's very little fundamental quibble with this insight. Since 100 years. Now, this particular application to climate change, let me just mention that carbon emission is a bit special because it spreads very, very quickly in the atmosphere. So if I emit here or I emit in China, it really has the same effect on the climate. The climate is also slow moving. So for practical purposes, there should be a global tax. It should be the same everywhere because no matter where you emit, the effect is the same. So that price tag that Pigou wanted us to use, it should be the same everywhere. And there are just thousands and thousands of economists who've signed petitions around the world to urge the adoption of carbon tax. And I've several times been asked, what is interesting in this area to work on? And the answer is, well, I don't know. We know the answer, what we should do. So is there nothing left? In some sense, no, because to say really smart things like fundamental new insights may be a little bit difficult. The issue is somehow settled, but I think the answer to this is still no. There's like so many things to work on, and I can list them more broadly, but I think here I have macro focus. So what can macroeconomists do? I would argue that the line of work that Nordhaus started, which is to formulate so-called integrated assessment models of economics and climate change, is extremely useful. Why? Well, for whatever reasons, policymakers are reluctant to just adopt the carbon tax. It's not that they say it doesn't work or something, it's just that they don't adopt it. And we can think about why. It's important to think about why, but it's also important to think about the more constrained problem, which is to consider policies that could actually be implemented. So let's look at them and let's study them, compare them, do some cost-benefit analysis. And I think this is also the kind of thing that people outside of economics don't really have the tools to do. We if anybody, are the people who have some idea how markets operate and how different regulations and taxes act, what their effects are, ultimately on emissions and on the climate. So here, the title of the talk is Suboptimal Climate Policy, because the idea is that's what we need to study. Studying exactly what the optimal tax is. I thought it was interesting some years ago. I still think it's kind of interesting, but it's more like an intellectual curiosity. From a practical perspective, I think we are so far from adopting that tax. So we have to compare various forms of other policies. There is a literature in economics called second best policy, which usually has the kind of approach that you say, okay, impose a constraint, and then your first order condition characterizing optimal policy has this other term in it, reflecting maybe that there's a distortionary tax or something that you have to take into account. This is not really what I have in mind here. It's not kind of more sophisticated theory. It's more just quantitative analysis using integrated assessment models, just comparing concrete policies and see how they fare. So for example, consider one policy package compared to another one and see how they help or hurt human welfare, given that they both have to achieve a certain amount of warming. I'm going to give you an example of that later on. So this is what I mean by what I think we can very productively do. So in this talk, I'll make reference to work that I've done recently with the people I listed on the first page. I'll go back, Jan Hassle, Conny Olofsson, and Michel Reiter. And these are really like more than one paper, but so I'll mention kind of three applications here. But let me first just say we develop a framework, an integrated assessment model that is similar to Nordhaus's model in spirit, designed to be quantitative. It's decentralized, so it's like supposed to describe markets. It's rich enough, I think, to be taken quantitatively seriously. We can use it to address important questions. It has heterogeneity because in this area, it's very important to distinguish effects of warming in different parts of the world and other important differences across countries. And I should say it is squarely kind of within the modern macro tradition, but we get away with simpler analysis than what we've seen in this conference the last few days, because the timescale at which climate change operates is entirely different than in business cycle analysis, which means that some assumptions we normally cannot make, we can make here. So we address three questions to illustrate suboptimal policy studies. So the first one is, what if you have the right kind of policy, and then I have in mind a global carbon tax, but you set it at the wrong level, and you can be wrong in two ways. You can set it too high or too low, but this is a very relevant question because, as I said initially, we are not really sure how much warming there will be and how big the damages will be. So it's relevant to think about the two kind of errors you can make, and one is that you can set the tax too high because actually the warming was limited and actually we were very good at adapting to climate change. or you can make the mistake that you say you don't use a tax at all, and it turns out that there's a lot of warming and we can't deal with it. So the finding there, to our surprise, is that the error when you set the tax too high is actually not very costly, whereas the tax setting no tax or a low tax is quite costly. So I'll show you how that works later. The second type of kind of suboptimal policy comparison is if you use the wrong kind of policy. So you set different tax rates around the world. So you let some areas not tax carbon. Why? Because they are the typical candidates are developing countries that you might argue kind of need the energy and so on. And then you look at the effects of that to achieve a certain temperature target. And turns out that looks very, very costly. I should say, when we ran these three, when we did these three things, we didn't particularly have in mind showing the results we arrived at. They just came as a bit of a surprise. And here the surprise was that it was more costly than we thought. The third case it was also a surprise, and here we look at a suboptimal policy of the sort, well, let's say we can't tax carbon. How good of a substitute is the notion of pushing green energy innovations and so on? So we have a particular way of implementing that, and given our calibration, we find that to be very likely be a very, very bad idea, in the sense that it doesn't really work in the benchmark calibration, and therefore seems like a hazardous thing to try. So you act under the belief that all we need to do, we don't need to tax carbon, all we need to do is come up with green energy. You may not deal with the climate problem properly. That's our conclusion. Okay, so I have about 15 minutes, a few more minutes maybe, and I want to briefly describe the integrated assessment model we have been using here. I should say it's a simplified version of a more complicated model. I'll get back to that later. But discrete time standard macro model, one final good. We have our regions, and they're all similar looking, except there's one producing oil. Oil is not the only fossil fuel here. The other ones use oil. This one region produces, but actually doesn't itself consume oil. So think of this as OPEC, some OPEC countries, and so on. Within each region, we assume there's a representative agent. Within each region, output is a simple Cobb-Douglas aggregate of capital, labor, and an energy composite. So it's Cobb-Douglas in the three inputs. Energy itself is a more a richer function. It's a nested CES in oil, other fossil fuels like gas and coal, and green energy sources as well. Then we have TFP levels around the world, and the way we model climate damages is like Nordhaus. We incorporate it as damages to TFP. It's kind of well known. You can put these damages in different places, but collecting them in TFP is at least it's convenient. All right, and then there's capital accumulation. It's neoclassical. We group fuels kind of both in how they enter in production and also by the cost structure. So I guess you could imagine some general notion of the more you extract of fossil fuel, the more costly it is. And in fact, that's the kind of formulation that Nordhaus has. What we do is something simpler, but I think gets you a big part of the way toward super realistic view, which is there's a lot of oil, and oil, by that I mean conventional oil, is very easy to access. So we assume the cost is really zero. It's not, it's not $5 per barrel, but it's literally zero. but it has quite limited supply. Then there is coal. There's just a huge abundance of coal, and coal, on the other hand, is the opposite. That it has constant marginal cost, and it's an industry that operates with zero profits. I think that's a pretty good intermediate assumption. Then there's all kinds of things in between. So we actually have fracking as a third alternative, and natural gas to us is like oil. So we kind of group them as some have constant marginal cost and zero profits, and some have pure rents but zero marginal cost. And you can get quite far with that formulation. All right, we have in this paper exogenous technical change, and the climate carbon cycle modules. We just work with what Nordhaus has. We then I just want to point out that there's perfect competition everywhere here. You might think there's trade between countries. Well, it's a one good economy that we're looking at here, and then so the only trade then would be over time. We rule that out. It makes the model simpler, but we've also found in related work that allowing this intertemporal trade is not changing things a whole lot if you calibrate the model properly, I think. There is trade in this one thing, which is oil for consumption goods. So there will be this R-1 regions buying oil from the last region. And just quickly, governments, they're all local. There's no world government. These governments run balanced budgets. They tax the fossil energy sector and rebate the tax revenues in proportion to incomes. That's makes the model slightly simpler to solve than if it's pure lump sum. Let me just make a few comments before I go to the results. Clearly, this model abstracts from a bunch of things. One, as I mentioned, intertemporal trade, it doesn't really matter that much, but we did model that also in another more complicated paper. Endogenous technology is obviously super relevant, especially developments of green technology. Here, I'm going to show you some examples of how you can study green technology, not by formally introducing endogenous technology choice into the model, but instead we're just going to say, oh, suppose there's all this green technology, then what? We don't so much discuss the cost-benefit analysis of getting it in place. That's interesting too, but I don't think I need that for the purpose here. Uncertainty is another much discussed thing. We don't have that here. I'm not so convinced that you always need to study uncertainty. I think the main thing here is that there's a lot of things we don't know. And I think you can, however, get a lot of insights by looking at the extremes. So that's precisely what I said we're going to do just in a moment, which is to look at, well, what if the outcomes are on the extreme end? What kind of mistakes would we have made? So I think we're dealing with uncertainty in that sense. I think there's another sense that uncertainty is relevant, is that you kind of worry about fluctuations. Here, I think the worry is not so much about fluctuations. The worry is that you're just kind of wrong, big time exposed. And that's more what we're looking at here, rather than taking into account the different probabilities of both good and bad outcomes. But certainly for some issues, some investment issues, for example, it's very important to think about uncertainty. Finally, nonlinearities. Tipping points are often mentioned, and here again, this model doesn't have these tipping points, and the reason is that even if I wanted to put it in, I'm not sure how to. There is really no kind of guidance in the IPCC reports or anywhere else for that matter, how to really, how to calibrate them, where to put them, at what levels of carbon concentration in the atmosphere. So that doesn't mean that I don't think this is relevant. So instead, what we do is precisely we look at this. Well, suppose that exposed there's a lot of warming for reasons that are not described within the model, or that the damages are really high. So we kind of deal a little bit with this question without formally modeling nonlinearities. My experience in this literature so far is that the people who try to model uncertainty and tipping points, they have to make all kinds of arbitrary assumptions about the distribution of tipping points, where they are, how likely they are that they're not grounded in anything, and then it's a little bit hard to know how to impose discipline. Anyway, so this is what we do. I should say that this model is so simple that you can add a lot of things to it without making it even close to infeasible to analyze. I'm looking at the time here, and there is the question of, like, in my past work, I've worked on what other people for sure call really complicated models. I mean, I've gotten many sites of the kind, if you want to study heterogeneous agents, that would be interesting, but it's a mess. For a mess, see Krusell and Smith 1998. That type of reference is kind of nice to get a reference, but so clearly it's not that I don't think the models should be unrealistic. I think heterogeneous agents is super important, but in this area, the way I've done work myself is gone back and forth between really complicated models and then much simpler models that actually do the job, the quantitative job of the very complicated models very well. And then I think it's fine to use a simpler model. So the particular model you're looking at right now is of the simple kind. You can really actually, embarrassingly enough, solve it in Excel. Well, but I don't know if it's embarrassing or not, but you can solve it in Excel. Here are the equations. I felt from looking at the presentations the last few days, I had to show equations otherwise, but now I'm kind of conveniently running out of time. So what you see here is just some utility functions, production functions. You see a resource constraint that looks like it could be a macro model. Here's the constraint where you run down oil, or is the reserves at time t. You run it down by consuming it to different regions. Here's the CS with the different energy inputs. Here's TFP. TFP is decreasing as a function of carbon concentration in the atmosphere. Our approximation is that you don't really need to describe how carbon concentration affects temperature. You can go straight, because over a large range, you get a very good approximation this way. There's carbon depreciation, how long it stays in the atmosphere, that's here. This is just global emissions. And if you want to keep track of temperature, here's the Arrhenius equation describing forcing, how that works. So that's that. Here are some things about theoretical characterization. The reason it's simple to solve is that you get very simple rules for saving, for extraction of oil, etc. So you can work with closed forms almost all the way over the finish line. Not quite, because you need to guess on certain things, but it's easy. Okay, so yeah, this page says what you have to guess on. You have to guess on oil prices, but once you have one, the other ones follow easily, so you need to guess on one price and just iterate a bit. Okay, so calibration in these kinds of papers is obviously central. Let me just say what we do. We have, in this case, 8 large regions: Europe, the US, China, South America, India, Africa, Oceania. And then the oil producing region is the OPEC countries, and we put Russia together with them. The energy, I already mentioned the kinds of energies we have. We assume there's only fracking in the US here. That's been the big one so far. The energy elasticities, like how substitutable is oil with coal and green and so on. Here we didn't know what to do other than to read the available literature, and it's a little bit all over the place. So the midpoint of the relevant elasticities that we thought we would use is 0.95 between oil and coal, or oil and green. Much higher between oil and fracking. They're very similar. Elasticity 10, but we try with other values because this is an important elasticity. We match the world distribution of income by setting TFPs. We make sure the marginal products of capital are actually exactly equal at time 0. The available studies I know suggest they are very similar, and the way we do that is by picking capital stocks in all the countries. And then we want to make sure we match all the energy data, stock of oil, amount of oil available in the ground. As I said, we literally assume an unlimited supply of coal, and the supply of coal isn't unlimited. We just assume a constant marginal cost. But there is so much coal that even when you use it at the rate you would be using it under zero tax regime, it takes a long time before you get even close to using up all the coal. And by that time, there's so much warming that I don't think that we'll end up going there, even with kind of evil world leaders. So I think the assumption of an infinite supply of coal is not so bad, actually, for the purpose of doing this type of modeling. Okay, here's the calibrated numbers on and the upper panels, just to make sure we match how big emissions are per region, and you see the model to the right, the data to the left. At the bottom you have world GDP, and you see, for example, here that China is kind of the big carbon dioxide emitter compared to the other countries. It doesn't have the highest total GDP, but it's the biggest emitter. Here's a basic point just about, this is not a particularly contribution of this paper, but the first 3 lines here, no taxes or just EU taxes, either just on carbon, just on coal or on carbon dioxide, they give you the high slope line here, which is to tell you if you have no taxes or just taxes in the EU, you see temperature just rising, actually looked kind of exponential, and by 2200 you have global warming by almost 8 degrees. And this is based on kind of midpoint estimates of how much warming we will get. So this is not like based on any extreme assumptions. Then move down to the next 2 lines. They are about global coal taxes or global CO2 taxes. You see they're on top of each other. That was true for the EU CO2 and coal taxes too, but basically the fact one is that using a global tax, and at what level are we using a tax here? Well, basically the EU ETS level that is currently where the trading rights are currently trading at, would do a lot to lower the temperature from like 8 in 2200 to basically 3. So a modest tax, and my view is that most of the calculations of what an optimal tax is land at a much higher level, but so adopt EU taxes and you see you go down a lot. And taxing only coal is the same as taxing coal and gas or petroleum. Petroleum really doesn't make any difference because there's so little of it. And finally, just the Swedish tax is comparatively very high. So if you adopt the Swedish tax, you are under 2 degrees by 2200. So that's kind of the background. Now, here's the experiment of a global carbon tax in place, but they're at the wrong level. So the black line here it shows you not temperature, but the consumption loss equivalent. If you use, say, no tax or close to zero tax, when in fact warming is on the right side of the interval that the IPCC indicates in the report. So not like outside their intervals, but kind of at the right end of their interval, and where damages are, say, at the right interval of what people who estimate damages find. So well then you see by 2200, you have basically consumption loss, which is then you can see the curves going up is at the level of the Great Depression forever. So that's a large loss. Whereas when you adopt a high tax, but it's high without really doing anything, but because the climate is not warming much, and to the extent it's warming, the losses are low. Here we take the left end of the IPCC interval and the kind of low estimates of damages from carbon tax. Well, then the cost is not very high of making that error. It's a cost because it's above zero. The intuition why the red line is so close to zero is that the sense in which you're hurting the economy is that you're adopting a tax when there shouldn't be one. So the optimum is 0. You use a tax that is not too large. You're kind of close to the optimum anyway. And this sector is not super central to the overall economy. It is on the order of magnitude of 5% or less of GDP in terms of costs. So that's why that cost just isn't very high. Whereas climate change, when it really rises to the level of 8 degrees, it's really a big deal, and not to tax when you should is a really bad thing. Okay, so that's the asymmetry of errors. We had no idea it would come out this way, and I think this tells you a lot. I don't think you need to solve the model with uncertainty to understand that a precautionary method here is to just go for the higher tax. All right. I'm just going to run through the last 2 experiments very quickly. This one is when you have a target of temperature by 2165. You want to reach heating by no more than 2.6 degrees. And in the upper panel, you set a common carbon tax on all the regions except Africa and India. You let them off the hook completely, no tax there. And what you see here is that the losses that the other countries make way outweigh the gains that you see for Africa and India. So it looks like it's a big loss. The orders of magnitude you might not think are huge. Well, look at this case. If you give China a break, actually, if you give China a break completely, China, you cannot reach 2.6 degrees only. Then if you give China a break, we'll heat much more. But here you see on the y-axis, the losses are even bigger. And certainly the cumulative losses by others way outweigh the gains for China. Finally, green technology, the green lines here in the graph. In 2 cases of estimates for our elasticity substitution between green and other fuels, tell you warming when you don't tax fossil fuel, but you instead give green technology growth a strong push. So every year it beats the other technologies in terms of development by 2 percentage points going into the future. And what we see here is simply that with green technology, you warm the world pretty much as if you hadn't done anything. It is not a good substitute for a tax in our experiments. So this is in absence of a tax. Essentially, because by providing cheap green technology, you will have a lot more energy. Output will gain, but you don't do what you need to do, which is to hurt coal. And green technology just isn't as effective at hurting coal as you would want. Even when you set the elasticity substitution to be pretty high number, it takes a long time before it really eliminates coal, and that's why this happens. Okay. Summary remarks is just to repeat policy things, but basically to say we have a very simple model. These are not definitive answers. We try to calibrate as carefully as we could, and these are our findings. So sorry if I went over 5 minutes or so. Or 2.
Very well, Per. Thanks for your presentation. We'll have James Stock from Harvard University provide for the next 15 minutes his discussion and commentary. You can go ahead, James.
Thanks very much.
In the meantime, if any of the people in the audience or the participants have questions, please remember to write them in the Q&A so we can read them after the discussion.
Can you just confirm that my slides are showing?
Yes, they are.
Okay, terrific. So this is a really great paper. I don't want to take, I could take half an hour discussing it. There's a zillion things in it. It's full of ideas. I'm just delighted that Per and his colleagues are doing this research program. I will try to actually take less than my allocated time so that we have room for some discussion. The paper certainly merits it. This has been a really active period in the climate sphere. I'm just showing this is going to be a very US-centric discussion because I'm an American, so I'm always American to US centric. So that's the way it goes. This is just a picture of like the burning fires in Oregon. Greta Thunberg, I think you probably recognize most of this, the launch by Ocasio-Cortez and Ed Markey of the Green New Deal protests against the pipeline. Well, you know, the economists really didn't want to be outdone here. So economists figured, gosh, what can we do? So, you know, so we'll write a letter to the Wall Street Journal. And so a bunch of economists wrote a letter saying that carbon dividends, carbon taxes are a really good thing. And that came out, that was a few years ago, came out a couple of years ago, and that came out in the Climate Leadership Council, which very sadly, Ted Halstead just passed away. He was in charge of, but they're continuing the push in his absence. In this paper, Per Krusell strongly lands on the importance of a carbon tax. I guess I want to stress, first of all, at a very high level, the message here is that it's important to study suboptimal policies. I completely agree. That's the world we live in. The policy space is really complex. And if you just say, we only want the first best, and if you don't have the first best, then forget it. Then you're not going to be, A, you're not going to be relevant, and B, you're not going to be helpful. So I'm totally on board with this program. There are three main findings in Per's talk. One is that it's better to be aggressive now than to blow it and to be too wimpy. The second is, the costs are asymmetric. Second is that it's important to do this globally. And the third is that a tax on carbon is strongly better than a subsidized to green. So I don't possibly have time to talk about these. I think the first two, if you work through the details of the model and you read it, those actually make a lot of sense. I'm going to focus entirely on the final point, which is the subsidy versus green versus a carbon tax. Okay, so within this context, I'm going to focus on, and I'm not going to talk about the model at all, both in an interest of time, and that's not going to be my comparative advantage. I'm going to talk about three features. So I think that an important feature that's driving this is the role of complementarity or substitutability of energy sources. I'm going to talk about some empirical evidence on that and how that plays out in the model. Basically, the short story is this is one of the drivers of this result, not the only driver of this result, is the structure of the model has coal and green energy being complements. And if coal and green energy are having some limited degree of substitutability, and if they're going to be, so think of the case that they're actually complements, then if that's the case, then your energy bundle is going to have to consist of both coal and green energy. And if you make coal expensive, then the whole energy bundle price goes up and you're going to use a lot less coal. If you make green energy cheap, then the whole energy bundle price goes down and you actually might end up using more coal, and that's what he finds. So in fact, subsidizing green energy can be a bad thing. Depends on the details of the settings, but that's at least my intuition. I'm going to talk about induced technical change. I think it's really important. He did mention that at the end, and the paper has a fair amount of that. I think that's something where I would start at the beginning. I think this is critical. And then I'm going to talk about my own view, which is I'm going to make a case against a carbon tax. So I signed that letter to the Wall Street Journal. I'm pretty much of a skeptic that a carbon tax is going to be it's pricing carbon is important, but it's far from the sole solution, and I think even far from necessarily the best solution. So substitutes or complements. I just explained this the basic idea here. There's essentially two views. There's the view in the paper that the coal and green fuels are complements and technical change is exogenous. There's a typo there. Technical change is exogenous. The alternative argument I'm going to try to make is that coal and green are substitutes, and at least some of the technical change is induced or endogenous. Right? So what's the argument for that? Well, in the power sector in the United States, it's super clear historically, looking at the data, that coal and natural gas have been acting as substitutes, so that the price of natural gas has fallen a lot because of the fracking revolution, and that has simply eased out coal, not just as base load, but actually as cycling as well. So coal use is going down substantially. I have a plot on the left this is from a paper with in last year that we have, where it tracks the decline in the use of coal, and it's basically driven by the relative price. So I have a picture there on the left, or the relative price versus the coal share in production, in energy production. And then there's a plot of coal use versus the relative price on the right. And it's not linear, but boy, you can see that relationship. So basically what's happening is that the natural gas is just edging out coal. It's substituting for coal. So, it's a little less obvious for wind and solar for technical purposes. The conventional wisdom at the moment is that wind and coal are actually plausibly substitutes, and that coal plants are actually shutting down because wind and solar, especially solar in the Southwest, is cheap. As you get to high levels of green penetration, maybe 80%, then there's a real problem because of the technology of wind and solar and not being able to provide reliable base load or to meet demand. So there it probably is more the case that natural gas and wind and solar are complements, so that you really need to have that natural gas as a peaker. But I think that's, but I think we're a long ways away from that. So what's the message? The message is that I think we need to be a lot more subtle in terms of the use of complements and substitutes, and I'll talk about that in a second. Second point, endogenous technical change. We have to remember that there's more than just the carbon externality. There's an R&D externality, and at least in some cases, there's a network externality. So for example, should you build a charging station? Well, that depends on how many EVs there are. Should you buy an EV? That depends on how many charging stations there are. You can be stuck in the wrong. I'm not going to talk about that, but it is important in some cases to remember that. In terms of the R&D externality there, I'm going to be thinking especially both, that's relevant for both exogenous and endogenous technical change. And if you have endogenous technical change, then you can leverage things like induced demand policies. And so there's some papers on induced demand policies. There's a nice book by Nemeth on why solar has gotten cheap. And I'm going to argue that this is really important. So, and I'm going to argue, since I'm just to discuss it, and I have essentially very little time, and I'm not a theorist, I'm just going to show some pictures of empirical stuff. So here's some empirical stuff that's been updated. And this is EVs. And this is, I'm going to go through this too fast for you to sort of pay attention to this picture, but boy, this is just like the coolest picture. So what this is a plot of electric vehicles. This is how much they cost, the manufacturer's suggested retail price in today's dollars, against the range, how far they actually go. And so one thing is that cars that go farther are going to cost more, and that kind of makes sense because the batteries are expensive. But what's really dramatic is that these early cars had a very steep trade-off. First of all, they were figuring out how to make electric vehicles. So this blue line is above the other lines, which are the more recent vintages, this being the vintages from 2017 through 2020. But what we've seen is not only is the price line shifting down, sort of the intercept, if you will, but actually it's flattening, so that they're learning how to, there's been learning by doing, or technological progress, or economies of scale, or some combination of those that has been making batteries a lot cheaper, so that now you can get a large, high-range vehicle for a whole lot less than you used to be able to. It's this shifting down, which is the technological progress. And then you think, well, what about substitution? Well, in the very short run, if you have an electric vehicle, it doesn't make any difference what happens to the price of oil, because you can't put oil in your vehicle. But in the long run, it can make a big difference, especially if the electric vehicles are cheap. So we could have a lot of substitutability in the longer run within the EV market, but within the transportation market. What do we see in the power sector? What do we see in the power sector? We're seeing also substantial decreases in price. And the offshore wind is really a nice thing to study, because this whole industry wouldn't exist if it weren't for government demand pull policies, and then also some technological subsidies. So this is something where we see demand pull policies implementing, achieving learning by doing and achieving economies of scale and really driving down the prices of offshore wind. A final point. So now I'm going to argue against a carbon tax. Point one is that my co-author on this, Gib Metcalf, will kill me if he's on the line here arguing against a carbon tax. But what we do is we study the effect of a carbon tax in Europe. So Europe has a bunch of countries that have a carbon tax. And here we're focusing on the tax part, not the EU CTS. What you find is that, yeah, it actually has essentially no effect on GDP. It has very little or no effect on employment. It does have an effect on emissions. So you implement a carbon tax of about $40 a ton on the transportation sector, and what happens? Emissions go down by about 4%. 4%. We don't need emissions to go down by 4%. We need emissions to go down by 100%. Okay, so why does that have such little effect? In the short run, because of low substitutability. So that gets back to the technological argument about EVs and the transformation of a diesel fleet in Europe to an EV fleet. So let me just make some comments here that are somewhat more technical. There was a brief discussion, Per had a brief discussion of exhaustibility of coal and oil, and I think he got it exactly right. Modeling coal as inexhaustible and oil as exhaustible. The oil, that actually plays a big role in terms of his results. Because coal is inexhaustible, then you can change the marginal cost of coal and you're simply going to use less. Because oil is exhaustible, you're going to use it all. Now, you can have that through an hoteling mechanism, or you can have it through a somewhat different mechanism that he has in his model. But if you're going to consume all the oil anyway, then a carbon tax has no effect. So this is like a really important lesson. If you have this view of substitutes, of complements, excuse me, a carbon tax is going to have no effect on oil because you're going to use all that oil anyway because there's a finite amount. And that case is made in this Heel and Schlenker working paper from last summer. Let me make some comments. So I thought that's another argument against a carbon tax, and that's another argument for thinking about this as needing technological solutions. Let me think some thoughts for the next steps in the paper. One is explore this thought substitution. My own conjecture is that maybe one way to go is to look at end uses that consumers like, which is using electricity for stuff like computers and lighting, using transportation for vehicle miles traveled, and using heat to keep their buildings warm. Within that, we don't really care whether it's produced by coal or electricity, by coal or by gas or by oil or whatever. So sort of how are you going to do that? So you can imagine having CES among these three end use goods and then having much more substitution within those goods, especially a longer horizon. So I bet that you find different types of results. Second is I'd suggest exploring group endogenous technical change, both because I think that's important as an economic matter, but also because it's really important as a political matter. I mean, the Green New Deal does not mention, I don't think it actually mentions carbon pricing anywhere. It certainly doesn't mention the carbon tax, and it does have a lot of things that are driving towards endogenous technical change. So I think we need to wrap our head around that in a big way. And another thing that actually is really out there is supply side policies. So supply side policies, keep it in the ground type policies, have to do, and I've shown a really important and like very little understood to the people who are not sort of in the nerd level of reading the Federal Register, an important development at the end of the Obama administration, which is programmatic, an intention to prepare a programmatic environmental impact statement to review the federal coal program, which was essentially to put a carbon tax on coal through the federal coal program on coal that was produced on federal lands. And so that's an example of sort of a centrist supply side policy. You're seeing down here this picture of the protesters. There's a less centrist supply side policy. If we think about that as either putting a tax, a way to implement a tax, or alternatively just to shift the supply curve in, how does that work here? And I think that's a ripe area for models like this one. All right, so those are my thoughts. A terrific paper, and thanks for giving me the opportunity to discuss it.
Very well, thanks, Jim, for your comments. Perhaps Per would like to reply. Take a couple of minutes to reply to Jim's comments, and then we'll move on to the questions.
Yeah, thanks, Jim. That was an excellent discussion. And, you know, I agree with a lot of what you say. Let me just first say that it's not that we have a view on substitutability. It's more that, you know, we went to the literature, we tried to find a way of capturing the various elasticities, and they are necessarily very aggregate in nature, and maybe we kind of picked numbers that we shouldn't have picked, but it's not that we have a view. And in fact, I mean, here's a point where I think this framework is very useful. If you disagree, if you think we modeled it the wrong way, and I think you're arguing that, then completely fine. Then, you know, how should it be argued? How should it be modeled? What is exactly how substitutable, what at what horizons? And the framework here is a bit simplistic, but I agree this is important. So definitely push more on that. My simple one-liner is just that we did not design this. We have no kind of prior on this. So maybe we got it wrong, but it got us very worried that people put all their faith in this wonderful Teslas. And it's great because you see the Teslas and they are great. But will it work in the world? Will it help the developing countries and all that? Will it kill coal all over the world, in China in particular? And you know, these are questions I think are super central, and we need to think about these substitutabilities, complementarities much more. And I'm just worried about like blindly saying green, green, green. Okay. The point about coal also, you know, a tax in Europe that is trying to affect the transport sector won't affect the transport sector because it's super inelastic. But let me also say that there isn't that much oil. So there's nothing that much wrong with the carbon tax if it doesn't affect oil use, because the amount of oil, like traditional, conventional oil, is very, very limited. It won't affect warming by very much. It starts getting serious if you think about deep sea oil and so on. Then the amounts are much bigger. But then we're into, you know, regions where the costs are much higher. And I think the reason why, you know, by the same argument that the coal industry lost out to these new forms of fossil fuel is that, well, you might say, well, the coal industry, they should just lower their prices and they would be competitive. Well, they can't lower their prices. Why? Because they're running with very thin margins. It's just not very profitable to sell coal. And imagine what a tax would do. The tax would do the same thing. It would shut them down too, because they don't have any margin. So I don't really, I mean, but anyway, a final point, because I realize I shouldn't monopolize time here, is, so I mean, I don't really think, I can see some problems with carbon tax. I don't think it's really so much of a problem. I think it would really hurt coal, and that's what we need to hurt. Unfortunately, we need to hurt coal in China, and that may be a whole different challenge. I mean, about R&D externalities, so I agree that if you have no carbon tax, it's important to subsidize green. Why? Because there are externalities in all forms of R&D, fossil and green, okay? But if you subsidize green more than fossil, you have this additional benefit of helping the climate. And that's a plus if you don't deal with the climate in another way. But if you deal with the climate by taxing carbon properly, there's no added benefit of subsidizing green. So kind of the optimal policy, I don't think, has R&D subsidies to green specifically. It's R&D subsidies to all R&D, but not specifically. So, but I agree, right now, we are not in a world where we are taxing carbon, in which case R&D subsidies are important. And I agree that we should be doing, it's not that I think we shouldn't be doing green subsidizing. My point is just, if we think it's just going to fix the whole problem, we are running on a hope, and I would like to see, you know, more evidence on this, how super substitutable it is with these fossil fuels, especially in China. And I think R&D also has to be of the sort not to make us make electrical bicycles in Stockholm. It has to be technologies that can be easily transported and used where there is a lot of coal in the world. We're not using coal in Sweden, so here, I don't know, doesn't really matter. We need to focus our attention where there's a lot of coal use, and especially in the future. So that's the end of my comments for now.
I can't resist making just one comment. So that's all fine. I actually don't think that we're very far apart in terms of how we're thinking about this. I can't resist sort of your comment about people putting all their faith in Tesla. Well, I worry about people putting all their faith in the CES production function. And actually, I think my comment is a little bit of, my comment is a little bit of a functional form. I think we could simply interpret my substitution thing as a functional form comment, and I bet you could get a lot of mileage out of really digging into some of the details of the technology, so you can come up with a good framework.
I would say neither the Tesla example or the CS that we use is the right thing. We need to go one step further. That I agree completely.
We have several questions. We'll start with one from Helene Ray. Please go ahead, Helene.
Thank you very much, Per and Jim. It was very interesting. So Per, would it be fair to, in a way, interpret your paper, given the global politics and the fact that we are never likely to have a global carbon tax, to interpret it as a very strong case for trying to put in place carbon adjustment taxes at the border? Let's say at the border of the EU and a few more countries. And if this is the case, shouldn't be the next quantitative exercise to try to quantify the possible effects of carbon adjustment taxes for specific sectors, maybe the most energy intensive sectors, and also to put in the model some kind of transportation sector if we are going to look at the pattern of trade. So would you see this as a fair interpretation of where you are going, and is it feasible?
I mean, yeah, I think border adjustment taxes and carbon clubs and so on that's a good idea. And my guess is that it's a very important way to deal with this, Helene, that's my view. About transportation, I'm not entirely sure, since I think that if you just do the cost-benefit calculation of conventional oil, I'm not convinced we should use less. But I think it's almost all about coal, and I'm not sure that, if we focus too much on transport, we forget coal, and we forget the massive threat. The threat of using up all the oil is just not a huge threat, and so the transport industry, I'm worried about just counting carbon units too a little bit, but I agree completely that implementing a tax indirectly through trade restrictions and trade tariffs and stuff, that would be a way to go. And we haven't done it, but you can do this in these models. We're working on trade extensions right now. That is a little bit more messy. Thanks. It's a good comment.
Per, I'm going to read you. I'm going to group three questions from the floor. They're all about the carbon tax. Frank Heinemann asks, why does it make no difference whether the EU only imposes a tax or no tax is imposed at all? Then let me read three questions. Gernot Doppelhofer asks, how do transfers between countries look like to make all countries sign up to a global tax? And finally, on the issue of too high versus too low taxes, Peter Zorn asks, what are your thoughts regarding intergenerational distribution of costs through the taxes?
Okay, I thought there would be three questions on the same thing.
Well, there are three questions on taxes.
I mean, number one, Europe doesn't really matter much because the used carbon emissions in Europe, they're just so small and it doesn't matter that much. So that's why no tax or tax, it makes a difference, but very small difference. The big thing is China, unfortunately, which is like particularly hard to get at. The second question was about what about the transfers across countries? What would they look like? It's true that there are winners and losers from climate change. And there are some big winners, and certainly Russia would need to be compensated. In general, many northern regions would be compensated. But I think in principle, it's doable. I mean, in terms of economics, it's doable to come up with these transfers. That's for sure. And you saw these pictures with, letting Africa and India not have taxes with China. It's clearly beneficial for the rest of the countries to get together and pay them off. I'm all in favor of that. I think in the end, I'm not a political scientist. I don't see that this is where politics is going. And okay, the last question was
about the intergenerational distribution of costs.
Yeah. I mean, this is all about the discount factor and so on. What should we do? I don't have a strong view on that. I think regardless of the view you take, I view climate change as a threat. It will affect future generations. I care personally about future generations. I think policymakers do. There's kind of no question that we have to deal with it, but I don't have strong views on exactly. I think the question about transfers back and forth to compensate it is also like a philosophical one, and I would like to stay away a little bit from that. I think you don't need to be very philosophical to realize that you have to do something about climate change. I don't think you need to take a strong ethical stand.
Very well. I think time is running out. Thanks very much to Per Krusell and Jim Stock for trying to shed light on a really complex issue. We'll reconvene at 4:10 p.m. Ellen Ray will chair the session, but we will have Cristina Arellano and Caterina Mendicino presenting. So have a nice coffee break and see you at 4:10.
Thanks. Jim, send me your slides.
Yeah, I'll send the slides in and they can be posted.
Okay, great, thanks.
Hello.
Hello, Caterina.
Should I upload the slides?
I think Kurt is sharing his screen right now, so
Okay.
Here we go. All right, so welcome back everyone to this last session of the Copenhagen Macro Days. This is going to be a session with 2 papers, and after that we are going to have a UniCredit Foundation Junior Award ceremony. And this is a session which is about crises. So we are going to start with a paper on twin default crisis by Caterina Mendicino. And then we'll have deadly debt crisis by Cristina Arellano. And I will just post again the ground rules in the chat. But remember that if you want to ask questions, please, you should use the Q&A function. Thank you very much. And now, Caterina, the screen is yours.
Thank you very much. And first of all, thank you to the organizers for including this paper in the program. This is a joint paper with Kali Nikolov from the ECB, Juan Rubio Ramirez from Emory University, Javier Suarez from SAMFI, and Dominic Supera from the Wharton School. And the focus of this paper is on the optimal level of capital requirement. This is a question that is still of great interest both for academics and policymakers, and at least since the global financial crisis, when we were confronted with high default rates among borrowers and remarkable declines in bank equity and bank insolvencies. And also, very importantly, the distress faced by banks depressed economic activity. And so the question of what is the optimal macroprudential calibration of bank capital requirement is a very relevant question. And it is still very relevant also in the context of the current pandemic crisis, where there are fears of the fact that the severe losses experienced by bank borrowers could spill over to banks and result in weaknesses in the banking sector that could give rise to a credit crunch, and so further exacerbate further depressed economic activity. And in this context, bank capital regulation or the regulation of banks could have a very important role in mitigating the feedback loops between the banking sector and the rest of the economy. And so, but still, this remains an open question. And in fact, we see that even among academics, some argue for very high levels of capital requirements, because with very high levels, it would be possible to reduce substantially bank failures and so generate very high benefits for the society as a whole. But others instead are more cautious, because there is the issue of potential detrimental effects on the supply of bank credit. So we contribute to this debate, and by addressing one that we think is one of the main challenges of the assessment of the optimal level of capital requirements. Because in order to be able to assess the costs and benefits of capital requirements, you need to have a framework that is suitable to capture the behavior of the economy in not only normal times, and by normal time I mean normal business cycle fluctuations, good times, normal recessions, but also during periods of bank insolvencies. And these periods of bank insolvencies are usually characterized by deep recessions and abnormally high default rates among borrowers and banks. And we refer to this joint realization of borrowers and bank defaults as twin defaults. This is still challenging because, what is generally very difficult and still missing from this debate is the quantification of the channels through which bank insolvency problems could and don't generously arise from the performance of bank borrowers. And this is difficult because it requires structural model of bank default risk, but it also needs the general equilibrium effects. So, and with this paper, we try to fill this gap. So the reason why we argue that it's important to capture the realization or the joint realization of bank and firm defaults is because although these episodes are rare, they involve large deadweight losses for the society. So of course, and this of course has an effect on the assessment of the potential benefits of higher capital requirements. So what we do in this paper is we start by building a structural model of bank default risk that microfounds the link between borrowers and bank default risk. And then we embed this model into standard macroeconomic framework with costly state verification frictions. And that, in addition, we think this is a very important step. We ensure that the quantitative properties of the model are in line with the data, because of course it is very relevant to match the data in a number of important dimensions, and including the frequency and severity of financial crisis. And our main result is that optimal capital requirements crucially depend on the assessment of the impact of borrowers' default on bank solvency. And I'm going, in the interest of time, I'm going to skip the reference to the literature, but this paper contributes to the literature at the intersection between macro and banking. So all the literature on the impact of capital requirements, or more broadly to the macro banking literature, the literature on financial vulnerability, and the one on financial crisis and non-linearities. And so I'm going to go directly into the model, and I will start. I will start by telling you that in our model there are households which include 3 members. So there are 3 members. There are workers that supply labor to the production sector and then transfer back the wage income to the household. And there are entrepreneurs and bankers that instead provide equity to firms and banks in this economy. And the household provides consumption insurance to these 3 members, and each type of member of this household family as a constant mass 1. So basically, at each time, some entrepreneurs and bankers retire with a certain probability, and at the same fraction of work, they retire and become workers, and at the same time, an equivalent fraction of workers instead become active entrepreneurs or bankers. And so we model the link between banks and borrowers by focusing on firms, but the same mechanism that we have in this model could be easily applied to other type of borrowers, like mortgage, if you want to think about mortgages and so on. In the framework here, we have firms that use inside equity and bank loans to finance their input of production, and they produce final goods. And then banks also use inside equity and outside funding, that in this case are in the form of insured deposits, to give loans to firms. And the household, as standard, maximizes the discounted future stream of utility, and were subject to the budget constraint. So the household at time T can consume, deposit funds in a bank, and then she receives wage income from the hours worked in the production sector, and the returns on the deposit, on last period deposit deposited in the bank. And why is this why here is the aggregate and transfer from the entrepreneurs and bankers that include the aggregate initial endowment that the household transfer to the entrepreneurs and bankers are at the beginning of their activity, entrepreneurial and banking activity, and also the transfer that instead these entrepreneur bankers accumulated and bring back to the family. upon retirement. And big T instead is the lump sum tax that is imposed on household to ex post balance the budget of the deposit guarantee scheme. And so for what concerns firms, we model firms as one period firms. And in our model, all the firms are ex ante identical, and they produce the final good, always using capital and labor. And big A here is a productivity shock. And firms pay for the input of production using equity and loans. And basically, they issue equity among entrepreneurs. And these are entrepreneurs with given that they only receive an endowment at the beginning of their activity, they have limited net worth because it depends on their ability to accumulate returns. And for these reasons, the firms also need to access external financing. And in our model, these are in the form of non-recourse and contingent bank debt. And we assume that firms operate under limited liability and can default on their debt obligations. And this means that in the case of default, they just walk away. They don't need to repay anything. The bank is going to seize their asset, but the firm can walk away. And the modeling of the contract is under costly state verification frictions. And here we actually explicitly model a contract between the problem of the bank and the firm. And you can think of, this is basically what this means, is that the bank in this model is going to endogenously applies the risk of default of the firm, and so it's going to offer a schedule of interest rates for different, you can think of this as a schedule of interest rate that the bank offers for different leverage choices. So in this way, the firm internalizes the expected cost of default in the firm's internalized expected cost of default in their leverage choice, basically. Okay. For what concerns banks, banks are also are also short-lived. This is only one period, and they also start being all identical. And similar to the firms, they operate under limited liability and can default on their debt obligations. Now, on the liability side, what these are banks. What the banks do is they issue equity among the bankers and insure deposits among the households. And but very importantly, there is no explicit contract between the depositor and the bank, because we assume that safety net guarantees in the form of insured deposits. So the risk profile of the individual bank is not priced by the depositor. And this is, if you want to think about in simple ways, so this is the main difference between a bank and a firm. On the asset side, we assume a segmentation in credit market. What this means is that banks operate on an island. So you can think of a continuum of islands, and in each island there is a representative bank that can grant loans to a continuum of firms that operate in this island. And it also operates under subject to capital requirements. So the banks are restricted by regulation to back with equity a fraction fee of the loans granted to the firms in the island. And this market segmentation, however, only applies to credit markets. So it doesn't apply to the factor of productions, to the final good, and not even to the funding in terms of equity and deposits, because these are freely mobile across islands. And so in every period, each banker and each depositor decide how to invest their net worth. I mean, let's talk about bankers first. Bankers and entrepreneurs decide how to invest their net worth in a portfolio of equity of all firms and all banks in this economy. And at the same time, from the depositor point of view, since deposits are insured and the interest rate is independent of the riskiness of the individual bank, all depositors always get the same interest rate on their deposits. So the segmentation is really only at the level of the credit market. And just to go a bit deeper into this, you can think of a firm I that lives on an island J and borrows from this bank J. So what this firm can do, she can default if the terminal value of its assets are insufficient to pay back the loans with the bank J. So here you have, so the terminal value of the assets are the value of production and the value of the depreciated capital. So if the value of production and depreciated capital are less than what this firm needs to repay to the bank, then the firm is going to default. And default here can happen for aggregate reasons. And this can happen because productivity falls so much that the value of production is bringing down the terminal value of the assets, but at the same time can also fall because the price of the capital falls remarkably. However, we do not only rely in this model, we don't want to rely on disaggregate sources of default, meaning we will let them play a role, but we are also going to introduce idiosyncratic sources. And the reason here is that in a model in which the only source of default risk is the aggregate, and banks and firms are ex-ante identical, it means that the default that is generated by, that can be generated by large changes in aggregate variables, it implies that all firms and all banks either default or do not default. And quantitatively, it's quite difficult with this type of framework to match the data. And I'm going to discuss further about this. So what we do here, we basically introduce some idiosyncratic reasons for default in the form of idiosyncratic shocks. And these are these two omegas that you can see in the slide. The omega in blue is what we call firm idiosyncratic shock, because this is a shock that is idiosyncratic across firms. So it's idiosyncratic across the continuum of firms living in the island. The red one instead is an island idiosyncratic shock that is idiosyncratic across the islands. So while from the point of view of the firm, these two shocks are indistinguishable, they are very different at the level of the bank, because the first one, the firm idiosyncratic shock, can be ex-ante diversified by the bank, since the bank can lend to all the firms in the island. The second shock, instead, it is not diversifiable at the level of the bank, because the bank only operates on an island. And if this island gets very low realization of these shocks, then it means that the larger number of firm is going to default, and this is going to create problems for the solvency of the bank. And what this setup brings to us, it gives us a very tractable way to model ex-post heterogeneous performance in default outcomes in this model. And just to check with the time, how are we doing? Okay, good. And so, as I said, now, this is the segmentation in markets. So let's go back. Let's see what actually happens to the firm. This firm, as I said, operate under limited liability, and so maximize the net present value of the equity holder, conditional on not defaulting, because indeed the firm is going to bring back to pay out the terminal net worth to the entrepreneur only if positive, because otherwise, and this is what you can see here with this VMACS operator. So in case of default, there is nothing left for in terms of net worth. And the firm operates subject to budget constraint and a banker participation constraint. So this participation constraint, it basically sets the interest rate on the loans such that the expected discount bank profits are sufficient to compensate for the cost of equity required to provide the loan, because the bank operates under capital requirements. And you can think of this participation constraint as an endogenous loan pricing schedule of the bank, according to which the interest rate will be set as a function of the leverage choice of the firm. Banks also operate under limited liability, and so they also maximize the net present value of the bankers, conditional on not defaulting. And the discounted profits of the bank here are given by the return on the loan portfolio and how much they need to repay to their depositors. And this maximization is also subject to the balance sheet constraint of the bank and the regulatory capital requirement. Now, as you see here, there is no explicit contract between the bank and the depositor. There is no participation constraint of the depositors, because deposits are always insured. So the interest rate on deposits is independent of the leverage of the individual bank. This means that given that the bank have always an incentive to lever up to the maximum. And so in this framework, the regulatory capital requirement is going to be always binding. How bank default happens? So bank can default if the return on the loans is not enough to repay for their depositors. And here what we can show is that the return on the portfolio of loans is a nonlinear function of the non-diversifiable island shock. And this means that the default of bank occurs when the large number of the borrowers of this bank is going to default. And we can show that this is consistent with bank asset being debt claims with unlimited payoff. And in fact, here, what I want to show you is the bank asset returns as a function of the island shock. As you see, when the island shock takes high levels, so the firms are doing very well. The firm in this island are hit by a positive shock, and so they are going to repay their debt with the bank. When the island instead is hit with the low realization of the shock, more and more borrowers are going to default. And so the bank asset returns are going down with the lower realization of the island shock. And bank returns are a highly nonlinear function of this island-specific shock. And when we look at the histogram of the asset returns, we also see that most of the time these banks are in good times, so they get the promised repayment. But this histogram feature a skewness in the left tail. So banks are exposed to significant downside risk and limited upside. Now, just quickly, I want to show you what happens if you instead you want to forget about this non-diversifiable island shock and the segmentation of credit into islands. Basically, as I said, you could introduce, in the absence of this idiosyncratic shock, you could, of course, generate default due to large aggregate shocks, but all the banks will be ex ante identical and ex ante diversified. So to generate default, you need very, very large aggregate shocks. and the behavior of the banks will be the same. There will be no heterogeneity in their default outcomes. So if you still want to, if you still care about the cross-section of banks, and this is what we think it is important to capture this heterogeneity in the health of banks that you see all the time, but is particularly relevant during crisis times. So you want to introduce another form of idiosyncratic risk. And this is basically the standard way used in the literature, this reduced form way, that it directly the returns on the portfolio of the bank rather than the underlying borrowers or the underlying loans, basically. And so the advantage of this modeling way is that it's very, very tractable. And in fact, it has been used in large models, multi-sector models with long-term debt, with monetary policy. So it's very convenient. However, what we figure out is that, first of all, it's a bit obvious that the banks in these frameworks can default even if the borrowers repay in full. So the model cannot capture these episodes in which the default of borrower, there is a large number of default both among banks and among borrowers. And then also bank assets are actually modeled like equity claims. They end up having unlimited upside. And here I just compare what you have already seen in terms of bank asset returns and the histogram of returns. The red one is our model, and the green one instead is this alternative setup. And here, as you can see, the bank asset returns are just do not have are not capped from above, and actually you can even, the bank can even get more than the promised repayment. What this is going to imply is that in good time, the model can underestimate the probability of default, because you can be here and think that your distance to default is very large, while if you are here, actually, you know that can take very little to get to the default part. And at the same time, also the distribution is symmetric, and it's much more difficult to generate episodes of very high probability of bank defaults, because it doesn't feature less skewness. So after building the model, we are very interested in validating the model against the data. So because we know that the assessment of the cost and benefit is model dependent, so it really hinges upon the ability of the model to match key features of the data, including the frequency and severity of this financial crisis that in our definitions are this crisis of twin defaults. What we do is we start by augmenting the model with aggregate shocks, because these are very, very useful to match aggregate fluctuations in both macroeconomic and financial variables. And so in addition to the two idiosyncratic sources of default risk, we add 3 aggregate shocks, a productivity shock and 2 risk shocks. And these are shocks to the standard deviation of the idiosyncratic shocks, basically, both to the firm idiosyncratic risk and the island idiosyncratic shock. So we start by calibrating the model using quarterly macro banking and financial data for the euro area over the period 92-2016. And here I will go very fast. In the interest of time, I'm going very fast on this. What I want to point is the fact that both in the model and in the data, you have a positive correlation of bank and firm defaults. And this is for the model to be able to capture this, it's really important. The island setup is really crucial, because if you model bank default in a reduced way that is disconnected, that doesn't necessarily come from the default of the firm, is disconnected from the reform of the borrowers, this correlation would be 0 or just reflect the aggregate, the impact of the aggregate shock, but anyway would be very close to 0, because otherwise you would need such big shocks that you will not be able to, the performance of the model will be very poor with respect to all the other variables. And an important thing is that this unconditional correlation actually hides substantial nonlinearity between this, the correlation of these two defaults. And in fact, here we're going, so what we do, a good way to look at this linearity is through quantile regressions. And here in this graph, I'm plotting the coefficient of this very simple regression run through the quantile of bank default in the data. And so as you can see, there are the sensitivity of bank default to firm default is very high at the higher quantiles of bank defaults, and then becomes very low and close to zero at the low quantiles of bank default. And when we run the same regression through model simulated data, we find actually that the model performs reasonably well also in this way. And of course, this is not targeted. This is just after calibration validation of the model. And again, this nonlinearity can only be captured through our imperfect diversification of banks and the island risk shock, because if you instead want to assume that these two defaults, that if you instead want to use a reduced form way of modeling bank defaults, then here you will get a constant line very close to zero actually. So in the next step, what we do, we split the data in three regimes. So what we observe in the data is that actually there are these three regimes. So there are periods of very low defaults of both banks and firms, and these are like the good times. Then there are periods in which firm defaults go up, but bank defaults do not go up, do not show any significant movement. And these are mainly periods of recessions. And then there are the twin defaults in which both the default of firm and banks spike up. And here you can see both the data and the model. What I want to start by pointing to the fact that the model can reproduce, I mean, this is actually implied frequency of this regime by the model and the data. It's very close. So 85% of the time you are in period of low defaults, and then you have recessions and you have twin defaults that are instead much more rare. And another important feature is the fact that, of course, periods of high firm defaults have negative effects on the economy, but when you are in the regime of the twin defaults, this it's actually the economic activity goes down by much more. And also in this case, the model can capture this feature of the data quite well. And here, just as a clarification, we define high levels of defaults above the 19th percentile, both in the data and in the model simulations. So I'm going to skip this, and I'm going to look at, actually, before moving into the policy implication, we find it interesting to see, to investigate the factors that can reproduce these periods of twin defaults inside our model. So what we see, I want you for a moment to focus on the red line. Here, what we do, we simulate the model 1 million times, and we look at the realization of defaults above the 19th percentile, both for banks and for firms. And this is the case of the red line. Instead, in the blue line, we only keep the realizations in which firm default is above the 19th percentile, whereas bank default it is not. So basically, this is what we're plotting here is a path to crisis that twin default crisis, and in the red line, whereas in the blue, it's a path to recession, let's say, because we have only the default of borrowers going up, but nothing substantial is happening to the banking sector. So first of all, as already suggested by the previous validation, we have that in the case of twin defaults, the drop in output is much larger than in periods in which only the default of firms spikes up. And then if we look at the increase in the default probability, we find that actually these are very close to what we have observed in the financial crisis period in the euro area. And then something that we value very much is when we look at the shock that generate these twin defaults, we see that actually these are not extraordinarily large shock, because here you can see this is the shock to the this is the island risk shock, and it goes up about 1.5 standard deviations. And also in this model, we see that this island risk shock is very important to generate an increase both in the default of banks. So it's this is the source of these spikes in contemporaneous spikes in default. Whereas obviously, if you only care about the default of firms, it's enough to have a firm to the dispersion of the idiosyncratic risk at the firm level. And then I want to show you what happens. Just
now you have to conclude soon.
Yeah. I just want to show you that if banks are less levered, actually the default, this is what you see in the dashed line, the default of banks doesn't go up to the levels that would justify these crisis episodes. And this is of course before because banks are more resilient to the default of borrowers in this case. And just to give some, how many minutes do I have?
Well, technically, you should be finishing now.
Okay, just
finished.
Just 1 minute then. So, just to conclude on the main question of the paper. So, what is the optimal level of capital requirement? So, first of all, in this model there is a trade-off, and there are benefits and costs of capital requirements. And on this, I want to be clear. So, there are clear benefits that come from the fact that higher capital requirement can limit the bank risk-taking incentives, and so reduce the probability of twin defaults. But there are also costs, because higher capital requirements increase the cost of funds for banks, and so this is going to increase the borrowing costs for firms and lower the equilibrium level of credit in the economy. So the net effects of these costs and benefits on the economy depend on which of these two forces dominate. And when we look at the welfare, this is the welfare of the level of the households as a function of capital requirement level. We see that, that in the baseline calibrated model, that is the black line, we see that there is a clear optimum that in this case is around 50%. And it reflects all the forces that we have included, captured in the model. But what is really important is that if you reduce the probability of this twin default, if you assume what we do here in this blue line, if you assume that there is borrower default is not the main reason for bank defaults, then the optimal level of bank capital requirement is going to be much lower. And this is because these bank insolvencies will bring costs to the economy, but will not be coupled with the cost that the economy has when, in addition to large insolvency of banks, you have also a large number of borrowers defaulting. So just to conclude, bottom message of this paper is that getting the probability of twin default right and economic losses associated with them is of first order importance when drawing conclusions on the optimal level of capital requirements. And thank you very much.
Thank you very much, Caterina, for this great presentation. So if you have a question, please put it in the Q&A, and the panelists can also let me know if they want to ask a question. I'm going to start, take the chair privilege. So I have, in fact, at least two questions. So the first one is, could you tell us a little bit more about the channel of amplification in this model and the possible channel of contagions? So it's very nice that you have the credit island in order to generate these twin defaults. Now, my understanding is that so the bankers hold equity potentially of other banks. So there is a linkage here across the banks as a possible contagion channels. How about when banks default, is there any persistent mechanism via the effect of that default on future returns of firms or future default risk of firm, or is there no channel of persistence there built in from the default of the banking sector into the future default of the corporate sector? So it's about the amplification and the persistence mechanism that you have in your model. So that's my first question. To that, I would add also that another potential linkage between the firm defaults and the bank defaults can also go through the government. Okay, we have seen that a lot in the euro area via the slowdown of the economy, the effect it has on the risk premium on government debt, and then the banks holding a lot of that debt. So is it something that you can think about relatively easily within your framework, or is it all together? Will it be a very hard extension? And I guess my last question is, you're talking about capital requirement, but there seems to be a more targeted policy tool that could be useful in your context, which is a maximum exposure rule that banks can have. If you put a maximum exposure to the island, then that could actually be a more targeted tool to deal with the twin defaults problem. So these are my three questions.
So let me, excellent, thank you very much. So these are really very good points. So one clarification first is that in this exercise, you see very little persistence, but because we are not targeting the persistence. We could rerun this by saying the default need to be high and have this persistence. And this could be something really feasible. Now, what you asked about this amplification, this is very interesting. So what happens in the model is that banks do not internalize the effect of their choice on the return on the equity of the whole banking sector. So all the banks in the model, of the banks of this continuum of islands, they are going to be equity funded through these bankers. And the individual bank in a individual island is not going to internalize the fact that she has on the return on equity of the whole banking sector. And this means also on the availability of an equity for banks in the following period. And yes, in this way, there is the model featured an externality, and what you said is correct, because the excess risk taking of a bank can have spillovers for the future availability of credit. And these episodes of high default of banks, of course, have effects for the supply of credit in the following periods, and there are feedback effects through the further default of borrowers that are going to be faced by the banks in the next periods. So the mechanism you describe is there. It's true, we could highlight this a bit more, also through looking also at the persistence of this crisis. But the amplification, the persistent effect is there. And also the amplification, as you see, you need very little, I mean, the shocks are not massive in this model. The shock that bring you to this crisis are not massive. And this is precisely due to the nonlinearity in bank asset returns. So once bank default risk goes up, and it's enough to have a small the impact of the marginal shock can be very large, because can move you into the default region. And so the impact is much larger than in normal times. For what concerns the government, this is also a very good point. We didn't think about how to extend the model to include these other sources of risk in the balance sheet of banks. But of course, one could assume that there is a third element that actually could affect both firm and banks, and capture the effects of sovereign risk. Now, you ask me how difficult it is. I don't think it's very easy, but I still think should be feasible. And regarding other type of instruments, this is also a very good point. So now, at the moment, we cannot really look at this maximum exposure rule, because the assumption is that for banks, the assumption is that each bank can only operate on an island. So the degree of diversification is not endogenous, and this could be a very big extension to endogenize this degree of diversification. But we could look at other type of tools that are less targeted to the solvency of banks, but that in this context could be still very useful, like leverage limits to the leverage of firms, for instance. This could also be a good idea for the analysis.
Thank you very much. Now we have time for, I guess, one more question. And so there's a question by Peter Sorensen here. The policy conclusions appear to be driven exclusively by solvency risk in your paper. So do you have a view of implications of adding also liquidity problems, say due to temporary shocks in a dynamic setting?
Yeah, I mean, the goal, the purpose was to focus on solvency risk. So this is what, this is true. We look at solvency risk because this was the main focus of the paper. Of course, it would be very interesting to also add liquidity risk, to also have runs in this model and look at other type of policies. But this would be a very big project, but definitely there could be interactions and useful results.
It's another paper. Okay, I think we are over time, so we have to stop here.
Thank you very much.
Sorry for if you wanted to ask a question, I had no time. So now we are going to move to the next paper, which is by Cristina. Cristina.
Yes, I'm here. So 1 second, let me see. You see my screen? You see my screen? Wait, Helene,
Yes.
is good?
Yeah.
Okay, great. First, thank you very much for the invitation to present our paper. I wish I was in Copenhagen. I've never been there, so I'm still looking forward to visit it at some point. This is joint work with Yen Bai and Gabriel Mihalache. And start by saying, of course, that the views here are my own and not necessarily those of the Federal Reserve Bank of Minneapolis or the Federal Reserve System. Okay, so the motivation for this paper is the pandemic that we're all living through, which has presented huge challenges for everybody. It's a highly contagious disease, it's deadly. Countries are imposing lockdowns on and off to control the disease, save lives. And advanced economies have engaged in large fiscal transfers to support consumption, ensure their citizens. So for emerging markets, this pandemic has brought additional problems. And what we're focusing here is on the debt component. So many of these economies are already highly indebted. They have a history of debt crises with rising interest rates, defaults, and they really have limited fiscal space, which makes it harder for governments to respond to support their citizens during lockdowns and to alleviate the health crisis. So for emerging markets, and this is what we're going to be doing here, this pandemic is going to generate, as for the rest of the world, a health crisis, an economic crisis, but also potentially a debt crisis. So just some data here. This is sort of the type of data that we've all seen in newspapers. Lots of, this is for emerging markets, the number of fatalities up to a few weeks ago. And it's a growing and steady epidemic in emerging markets. I was hearing a presentation by Robert Barrow about the Spanish flu, saying that back then, sort of the countries that were mostly hit from a health perspective were the emerging markets, Pakistan, India, and we're seeing that. And his prediction was that it was going to be the same this time around. It took a little bit longer for the emerging markets to get really high levels of epidemic of cases and fatalities, but for several months we've seen that already. The other component for emerging markets is that the official deaths are probably underestimating the actual deaths, and some estimates a couple of months ago from actually the New York Times suggested that excess deaths to official deaths were very large. For example, the order of 2 times for Turkey, 15 times for Ecuador. So the emerging markets are also facing, somewhat constrained debt markets. So several countries have already defaulted on their sovereign debt. They're actually, Ecuador, for example, already defaulted and already started to enter the process of restructuring the debt. But sort of Argentina, Ecuador, Lebanon, and several other countries have defaulted on their sovereign debt. And countries that have not defaulted on their sovereign debt have experienced rising interest rate spreads. These are spreads on sovereign bonds, between 200 and 400 basis points increase. So what we're going to do is we're going to think about a framework here that has sovereign default, sovereign debt crisis, and an epidemic. The epidemic in the framework is going to create a health crisis, and we're going to be following closely the models that I'm sure we're all familiar with at this point, the susceptible infected recovering disease model, that basically generates dynamic paths for these population groups. On the economy side, the economy, there's going to be a centralized government here that decides sort of lockdowns for the economy to control the epidemic, and is also going to borrow internationally and also can default on the debt. So borrowing is going to be useful to support consumption during this epidemic, but the default risk is going to limit the fiscal capacity of this government to basically support consumption. In this framework, we're going to have that the epidemic, which is going to be an unexpected COVID shock, is going to generate a debt crisis with default episodes and with high sovereign spreads. So that's going to be one of the feedback loops. But also the fact that this economy faces default risk, that is going to make lockdowns and mitigation policies more costly due to the inability to support consumption, which in turn is going to make the health crisis more severe. So I'll show you how this works. In this framework, the debt, how much debt and how much indebted the country is, and the possibility of the country to support consumption is going to be an important driver of both the debt crisis and also the severity of the health crisis. So in this framework, we are going to analyze debt relief policies, policies that can potentially support consumption, sort of just similar to the type of policies that we've seen the IMF, IDB, and other organizations give to engage in transfers, or actually loans. It's going to be loans to emerging markets. And we're going to find that this is going to be very useful in terms of preventing defaults, saving lives, and supporting consumption. So basically, what I would like to get to you at the end of this talk is to present some details on how this framework can produce a combined triple crisis here, health, economic, and debt. And the second point is that sort of our framework is, through our exercises and counterfactuals, really support the debt relief policies that these organizations have been engaging in. Let me preview a little bit the quantitative findings. So we're going to try to take our model to the data by looking at data for emerging markets in terms of epidemic dynamics and recessions, actually. And we're going to find that in this quantitative model, it's going to lead to a long debt crisis for the average country that we consider of about 44 months of defaults and rising spreads. We're going to have we're going to characterize an optimal lockdown policy, which turns out to be about 17 months. That a lockdown policy that it starts 2 months into the epidemic, lasts for about 17 months. And most of those 17 months actually have very moderate intensity of lockdowns, but there's going to be about 6 months of intensities above 20%. We're going to find that these lockdowns are going to reduce fatality substantially from about 0.5% of the population to about 0.2% of the population. So that's how deadly the epidemic is going to be in our framework. Of course, this is going to be, the epidemic leads to a large welfare loss of about 1% in consumption equivalent. So this is really costly. So that's the baseline. We're gonna find that, you know, if the economy would start the epidemic with less debt, that would have been great, because they could have used additional borrowing to support consumption, avoid debt crisis, and allows for more mitigation. In terms of the debt relief policies, we're going to find that a program that, for example, so financial assistance entity gives the country a 10% of output loan, and that is going to be repaid, okay? Then that is going to, so when the financial assistance is going to break even with that loan in the context of our model, that is going to benefit the country by about 6.6% in present value. So it's a large beneficial transfer. And of course, the benefits from this type of debt relief are going to be coming from avoiding the debt crisis and inducing better mitigation policies that can save lives. So a lot of action, a lot of work in COVID, and this is, you know, it's hard to, you're at home and you're thinking about this. So I think we're all sort of writing papers on it. A little bit less on emerging markets, but I think that there's some, papers already, and I think that more is going to be coming. Okay, so let me jump to the model. So this is going to be a small open economy model with a government and homogeneous consumers. The economy is going to be hit by an unexpected epidemic, and the epidemic is going to follow a standard epidemiological SIR model. The economic side is going to borrow from a sovereign default literature. So the government is going to borrow internationally and can default on the debt, but it's also going to decide sort of these lockdowns, these mitigation policies in a centralized fashion for the economy as a whole. And both defaults and lockdowns are going to be endogenous. So the government is going to be choosing them every period, and it's going to be with varying intensity. So the lockdowns are going to be sort of small or large, and also the defaults are going to be, the government can default on part of the debt, and how intensely the government defaults on is going to be endogenous as well. We're going to analyze the dynamics during the epidemic in terms of the population groups, in terms of the economic outcomes, consumption, output, and also in terms of the defaults. And finally, I will show you the debt relief counterfactuals. So the preferences here are going to consist of two types of goods, if you will. One is just our standard consumption of goods with concave preferences over consumption. And also there's going to be a value of life. And the way that we're going to model this is that there's a cost for fatalities, and the cost is driven by this parameter chi, which is going to be standing in for the value of life. Output in this economy is produced with labor, and labor is going to depend on the population size n, and it's also going to depend on the proportion of the population that is not in lockdown. So when the government, if lockdowns are of size L, then labor input is going to be reduced by to 1 minus L. There's 1 unit of labor input per person, and the aggregate employment is just going to be 1 minus L times N. And output is going to be produced with this labor input, and is going to also depend on an economy-wide productivity that is ZT. Now, the government debt and default is going to be following some earlier work that I have with Javier Mateos Planas and Victor Rios rule, where so it's fairly standard. So we have that the government is going to use the international debt. So it has some debt that it has to pay, BT, and is going to use new borrowing here in this notation, LT, that they can borrow at a price, QT, to basically support consumption so that consumption can deviate from production every period. The government is going to choose to default on the debt that it owes. BT can choose to default if it wants to default, and the default intensity is going to be sort of varying and given by this variable DT. Now, why is a default beneficial? Well, default is beneficial because the government doesn't have to pay the debt. But as is typical in this type of models, there has to be some cost of default. Otherwise, the government would always default. So what we're going to assume here is that default is going to, if the government defaults, there is going to be a cost in terms of productivity that is going to be proportional to the intensity of default. Now, if the government defaults on the debt with intensity D, then what happens is that the fraction of that defaulted debt, the kappa fraction, is going to accumulate over time and is going to increase future debt obligations. And this is actually consistent with the evidence that we documented in this previous paper and other work as well, that really default for these emerging countries, sovereign default, is not really a fresh start. But actually, they start with a lot of debt after the default as well. So this is our way of modeling that. The price of these loans, QT, is going to compensate for any default cost that the lenders are going to encounter, and it's going to be sort of set so that these lenders are going to break even in expectations. So in this framework, as in standard default, sovereign default type frameworks, default is going to be more likely when the economy has high levels of debt, when it has low output. This is when paying the debt is most costly, and when the price of the bonds, new bonds, are low, meaning there's low repayment prospects and spreads are high. Now, the epidemic side, so there's going to be this SIR model. The population transits from starting from all the population basically as a susceptible population. It transferred to being infected, and then they sort of recover or die. A key building block in this framework is how new infections occur. And this is how, what the function is that makes people transit from being susceptible to infected. and we're just going to follow a standard approach here, that the probability of a susceptible person being infected is going to depend on the fraction of people that are infected. So the more infected their people are, the more likely a susceptible becomes infected. And also by this sort of parameter pi x, which is going to be related to this sort of famous R naught that we hear in the news all the time. So higher pi x, higher R naught, that's going to mean that there's going to be a higher probability of being infected if you're susceptible. Now, as the epidemic progresses through the economy, the proportion of susceptibles shrink. Okay, and but if you become infected, then there's a probability that you stay infected. This is going to be a weekly model, and so the amount of time that people remain infected is more than a week. So there's going to be a probability that you remain infected for more than one period, and also the new infections are added into this infected pool. Infected individuals are going to die at a rate pi d, okay, and the rate, the sort of the fatality rate, case fatality rate, is going to depend here on the fraction of infected to take into account these healthcare capacity constraints. And if you did not become infected, then if you did not die from the disease, then you're going to become recovered. You should think of this as sort of the probability of dying is sort of between, I think, 0.2% and 1%, okay? And the rest is going to, 0.998 or 99 is you're going to recover from the disease. Now, what we're going to do, so this is the standard model with no mitigation. This is the standard SIR model. Where we're going to add here is the possibility to change this new contagion with lockdown policies. And here we're basing our analysis on the work by Alvarez Argentalipi and others actually that have been using this type of framework. So if there would be a lockdown policy of size L, this is going to reduce contagion. This is going to be the benefit of lockdowns. And they're going to reduce contagion by a fraction theta L. And you should think of theta as the fact that even if there's lockdowns, people are still at home, you still go to the grocery store, etc. So there's still possibilities of getting the disease, even if you're not, working. But basically, the lockdowns are going to alter the size of the sort of the impact of how many people are infected in a particular period, okay, particular week here. But also, it's going to alter the dynamics of the epidemics, the endpoint of where this epidemic goes. Okay, so this is going to be my last slide of the model. Basically, this has these two sort of modules, the SIR model with the epidemic and the debt with consumption and production. And we're going to combine them into a unified framework. So the state variables of the government, and so this is a dynamic program here. The state variables of the model are the epidemic groups and the level of debt that the government has. And the government is going to choose new borrowing, default, and lockdowns to maximize its value. And it understands that the dynamics of the population groups are going to depend on the lockdowns. And it is also going to take into account that the price of the debt here is going to be this function that remember, the prices of the debt are going to compensate lenders for future default risk. And default risk is going to depend on the evolution of the epidemic and the level of debt. And so the price here of the new loans are going to depend not only on the level of debt, but also on the evolution of these population groups. And the government understands that, takes as given this price function. So the main point here is, if you see it, so if you think about periods where, suppose when the epidemic hits, that is going to lead to a sort of the government is going to want to implement mitigation strategies and lockdowns to basically, bring down the epidemic. That is going to reduce output, okay? And that also is going to reduce future repayment prospects. So it's going to lead to a declines in the price of the new loans. Once there is a decline in output and decline in increases in sovereign spreads or declines in bond prices, that is going to there's going to be a force that is going to generate current defaults. So that's going to put pressure into the government to generate to default, because basically they like to consume, and if they cannot really borrow to support consumption, then they're going to have to default. That's the sort of this blue line here, the first loop. Second, of course, now if you have this default is costly, like in our model, and you do not want to default, okay, and you don't want to reduce consumption as much, then that is going to make lockdowns more costly from a consumption perspective, because you cannot really have the fiscal capacity to support consumption. So that is going to make lockdowns more costly, and in turn is going to make them smaller, which is going to make the health crisis more severe. Okay, so that's the complete of the model. Let me move on to the quantitative analysis. So we're actually, this is still a little bit work in progress. We're trying to use emerging market data on fatalities and output during COVID to parameterize the model. And then after that, and I'll show you how where we at in terms of that, then we want to look at sort of the implications of our model for other time paths of lockdowns, consumption, defaults. I'm going to show you, maybe not today, but there's some, there's these policy rules that now defaults are also going to depend on the epidemic. And show you a little bit about the role of debt and the counterfactuals. Okay, so our strategy for, maybe spend a few seconds on this calibration. So the strategy for us is we're going to take some parameters from previous literature. For example, some of the default cost parameters we're going to take from this earlier paper where we estimated them for 35 emerging countries. We're going to choose some parameters that are standard. For example, the debt in the model that I presented is short-term debt, but in our quantitative analysis, we extended to long-term debt of about 6 years. And then we are going to have these, so this is our functional form for the fatalities, how the fatalities evolve. And if there's going to be a linear component, which I guess is the more standard SIR type model, that fatalities, there's like a constant fatality case fatality rate. And there's going to be a fatality rate that is going to be increasing in infections, meaning the idea here is if there's a lot of infections around, that clogs up the hospitals, and that might increase the fatality from COVID. So we're going to do a sort of a matching, moment matching exercise to estimate 5 parameters. So the first parameter is going to be the value of life. Second one is going to be how contagious the disease is, this underlying R0 parameter. Third, we're going to have, and fourth, are going to be these 2 coefficients here on how deadly the disease is. And then we're also going to calibrate one of the cost of defaults to have a debt to GDP, debt to output ratio of 30%, which was sort of in the range, in the average for emerging markets prior to the epidemic. Turns out that sort of this moment matching exercise, and I'll show you how we do this. This is going to result in an R0 of about 1.55, which is going to be lower than initial estimates. So in initial estimates, and actually I'll show you some experiments, Diamond Princess type estimates of R0 of 2.3, the epidemic just goes too fast relative to the data and is too deadly. And this is sort of the case fatality rates that I showed you. This implies that this is the case fatalities from 0.25% to 1%. The value of life that we end up obtaining from this exercise is actually close to the estimates for emerging markets from Viscusi and Masterman, about 88% of the value that they report an average for emerging markets. We're also, for calibration purposes, going to use industrial production that is coming at the monthly frequency for a bunch of countries, and we're going to adjust the COVID fatalities from the world meters that we all follow by a factor of 5. So, if anything, this is within the line of sort of these New York Times articles, and we're in the process of trying to get excess deaths for emerging markets, which hasn't been so easy to obtain. Okay. But this is going to be basically the epidemic is going to be at the level of the US. So this is the data, okay? So what we do is we collect data for about 30 countries from Africa, Asia, Eastern Central Europe, and Latin America. And we're going to this is the average across these countries at the monthly frequency for fatalities, daily fatalities per 10,000, okay? And just to give you a sense of the magnitudes here, so this point like 0.05, okay, this is like 0.05 out of 10,000 deaths per day sustained in a month. That is about 1,500 deaths in the US a day. Okay, so this is sort of the scale. So that's this is going to be almost the peak of the epidemic. In terms of industrial production here, so these are declines relative to at the beginning of the year. So the decline is about 20% decline in industrial production. Again, this is fairly uniform actually across many countries in the world, advanced economies and developing economies. Okay, so we calibrate our model. Remember those case fatality parameters and the value of life to basically get at the average of these 4 or 5 numbers here, okay, for output and deaths, and also to match the endpoint. Okay, so that's what we do. And the model sort of has a good calibration fit, but also gets a bit of the timing right. Okay, and what you see here is that what the model predicts is that there might be a little bit more of an increase. Maybe it's already happening. We have to update. This is something that when you're working on something that is changing over time, the calibration is like a moving target because every month adds an extra point. But this suggests that basically the epidemic is going to be with us for a while, but it should, there's a single peak and it should come down, next year, but it's still going to be around. And the output, a little bit more decline, but then recover. So this is our moment matching exercise. Let me just now go back to the other paths, okay? So maybe we should do it monthly, but I'm going to go back to our our model, our weekly model, just to give you a sense of how this works. The previous one was time aggregated to match the monthly data. So this is over here on the left, the total fatalities from the epidemic. So we find that at the end, about this epidemic is going to be basically resolved after maybe 1.5 years or so, and then it's going to level for the fatality, the death rate of about 0.18% of the population in emerging countries. Just for reference, how much lockdowns are controlling the epidemic. So absent lockdowns, given our parameters, our estimated parameters, this would imply that the epidemic would, be much more deadly, and it would have implied. So if you think about the Diamond Princess estimates, which I guess we were all looking at several months ago, sort of the estimates that you would actually, this is not true. This is actually for much lower than Diamond Princess estimates. I'll show you the Diamond Princess. That's about 1%. This is about less than 0.5% of the population dying without any lockdowns. In terms of the optimal lockdowns, that's the shape in the right. So what this implies is that, the lockdown is going to start 2 months in, is going to last for a long time, and is going to be about 6 months with intensity above 20%. Okay, and then has this long tail where people are still going to be, doing some mitigation, and but it's going to be more minor. So in terms of infections, so lockdowns are going to sort of flatten the curve. It's going to reduce the peak infections from about 7% to about 2%. The number of people that eventually get the disease, absent lockdowns, that would be about 40%, a little bit over 40%, and I'm sorry, 60%, this is the susceptibles, and sort of with lockdowns, that is going to go to a bit over 45%, 60 to 45%. Okay, so what about the economic outcomes? So what you see here is that, so output, this is just going to reflect mainly the lockdowns. So that's going to reduce labor inputs, and that's going to depress output. So that's what's generating this sort of sharp declining output and a recovery. Consumption drops less, so there's still some possibility to use financial markets, and but it's still quite a substantial decline of consumption of about 15%. The model is going to generate a debt crisis, so there will be default. The model predicts defaults for about 44 months. So eventually, this is just the partial default. So this variable D. So the government defaults more intensively during the lockdowns, and then sort of it starts to default less. If I elong this, eventually this will go back to zero. The model goes back to a steady state that has no default. Now, why is so one of our main points is that the default crisis, the debt crisis, is more persistent than the health crisis, okay? So maybe this is a better plot for that. So if you see here, basically the epidemic is resolved in this model about a year and a half from the start, okay? But the debt crisis is actually not resolved even after 3 years. It's resolved after 44 months, okay? If I would elong this, it will go back to zero. And the reason is because during the epidemic, the debt increases, okay? And it only slowly falls to the pre-epidemic steady state. Now, the other thing that you want to see here is that the increase in debt with this economy that has default risk is fairly narrow. So the increase in debt is about 2.5%. So the fiscal space is really, limited here. But basically, from this is just collected all the pictures that I showed you earlier. The epidemic is going to generate an economic crisis with depressed consumption output, debt crisis with prolonged defaults and high spreads, and a health crisis that has sort of a substantial percentage of people dying. Just to give you some, this is just summary statistics that I'll get back to.
To
yes.
But concluding soon now. Yeah.
Oh, okay. Okay. This is just I give you a summary. I mean, I guess that the main point here is that this is a very costly epidemic. This is about 50% actually in present value, in consumption equivalent, present value in terms of output from the epidemic. Now, lenders also lose from the epidemic, but it's just orders of magnitude smaller than the country. Let me conclude with the debt relief program. So what we do in this model is we basically evaluate a program where a financial assistance entity gives a long-term loan that is default-free to the country of 10% of output. And this debt relief program has zero net present value for the financial assistance entity, okay? So what happens here is that the welfare gains for the country, this is our baseline country, and we have some comparative statics if this program were given to countries that have different levels of debt. But for the baseline country, this is about welfare gains of about 6.6% of output, okay? Where are these gains coming from? These gains are coming from almost an elimination of the default episode. So the debt crisis is reduced by about 32 months, and also by a reduction in deaths. So about 2.3% of the deaths are prevented with this loan. If this economy with the just large where are these gains coming from? Better mitigation, preventing debt crisis, and relaxing financial frictions. How does this work if this program is given to economies that have different levels of debt? Okay, so if this loan that is default free but will be repaid, so it doesn't have any cost for the financial assistance entity, is given to economies that have lower levels of debt, then they were not having so much of a debt crisis to begin with. Okay, so there's really going to eliminate completely the short debt crisis that they had, but they're going to use it for much better mitigation policies, and they're going to be able to reduce the debts more. Okay, so in this case, for a low level of debt economy, this is going to reduce about more than 5% of the debts from the loan. What happens if you give the economy this loan to an economy that has high levels of debt, say 40 or 50% of debts? Then basically they're going to use this loan to reduce the debt crisis. So they were starting from a debt crisis of like 10 years here, if they would start with a high level of debt, but the loan actually reduces it substantially, but it does not really reduce improve the health crisis. They're not going to use the loan for better mitigation. The gains on this loan are non-monotonic with respect to the level of debt, which suggests that it's best to assist economies with middle levels of debt, basically economies that are marginal, and even better if they're marginal on the two costs, which is improving mitigation to really make the health outcome better and reducing the debt crisis. So with that, I'll conclude. So we've sort of developed this framework and make the case that the pandemic creates very large challenges for emerging markets, and that's particularly relevant because of the limited fiscal space with default risk. Lower debt burden could be useful for the I didn't have time to show you that, but if economies start with low levels of debt, that's going to be much better for them. And debt relief programs have large social value. Thank you.
Thank you very much, Cristina, for this great presentation as well. So we are now opening for questions from the audience. So please use the Q&A if you have any questions. And we are going to start with a question from Morten. Morten?
Yeah, no, very interesting, Cristina. So one thing I was thinking was, so you could sort of think that there are two differences, or many of course, but two big differences between richer countries and emerging markets and also poorer countries. So one is the fiscal space, and I guess the other one is simply like in rich countries, people take action to avoid the risk of some of these, getting the virus. So even without a lockdown, people are there's still gonna be a big economic hit because people take that action. That may be harder. That may be something people in lower income countries can less afford to do. So have you got any idea about whether that's sort of that second source is important or not?
Yeah, so I guess one way that we've addressed that point is that, so we don't really take a stand on whether the mitigation is really like policy induced or self-mitigation. People are just, not engaging in market activities because they want to protect their own lives. So we don't have that, but we do have that when there are more risks to, not be able to support consumption because of the default risk or because you have high debt, then you are you're basically forced to do less mitigations and continue to engage in market activities. If you would have you could think of that as more of a developing country, and the developed country, because people have their own savings or the government is doing the transfers, then they're more willing to engage in self-mitigation because they don't really need to go to work, So in that sense, we address it, but we do not have, and I think that is what your point, we do not have, for example, the informal sector, okay, more explicitly to say, well, if you have a higher percentage of, which is going to be very important for developing countries, if people have to go to the market to sell their products and they, that's their source of income and they don't have savings and the government is not giving them any money, you know, it's extremely costly to stay at home. So we don't have sort of that sort of informal sector, which I guess is going to be sort of more to what you're saying. But I think we could think about maybe adding it, but we haven't done that. We do have this other way to think about sort of that sort of developing and developed connection. And actually, we do have now an example in the paper that adds sort of what's the role of having default risk, you know, eliminated, and the way that you support consumption. I mean, consumption can just be completely flat, you know, or a little bit lower from a present value perspective, but suffer almost nothing in terms of because of the lockdowns, basically.
Thank you. And we are going to have a last question by Federico.
Hi, Cristina. Thanks. This was really, really interesting and needed. I had a short question, something that may be more relevant given the demographics in emerging markets, about the long-term impact of school closures on accumulation of human capital. There's been some estimates that this, even the lockdowns in OECD countries might severely affect, especially children from low-income families. And I was just asking if this is something that could enter into your model, and whether this is something that would be more important maybe in some emerging markets.
I think that sort of the impact on schooling is probably important everywhere. I don't necessarily think our framework, I have to think, I haven't thought about if we could add it, if there's some interaction with the fiscal space. I guess there might be, but I think that this, I mean, for emerging markets, you know, given that the government is providing a lot of the public schooling and so forth, and I guess, you know, if there's no money because they cannot borrow and because tax revenues are low, then that is going to put extra constraints also from a sort of a government public finance perspective to funding sort of health and education and so forth, that basically would add, you know, compound the fact that you have the lockdowns. And in sort of, it's related a little bit to what Morten was saying. I mean, kids in developing countries have less a chance of having internet to do, you know, or they might have one cell phone, but then there's 5 kids in the house. So how exactly you're going to do that? And I think that that's certainly very, very relevant. So I haven't seen people done that in a paper, in another paper, but, you know, I might be missing something, or maybe somebody's writing it right now. Yeah.
Thank you very much. Well, I would like to really thank again Cristina and Caterina for wonderful presentations on very important topic. And now we are going to move on to the final part of these Copenhagen Macro Days, and we are going to have the UniCredit Foundation Junior Award ceremony. So this year, the award ceremony is dedicated to the memory of Emmanuel Farhi, who, as you know, has sadly left us in July over the summer. And so before proceeding with the award, I would like to invite Jim Stock with us to say a few words about Emmanuel. Jim, please.
Thank you very much. And I'm sorry that I have to be here for this purpose. Can I, yeah, I probably still have screen share capabilities. Emmanuel Farhi's passing on July 23 was a tremendous loss to the Harvard economics department, to its students, and to the economics profession as a whole. I will say a few words about Emmanuel here, but I'd also direct you to the moving tribute by Jean Tirole at the World Congress of the Econometric Society last month. In addition, the Harvard Economics Department held a virtual memorial service last week on what would have been his 42nd birthday, with more than a dozen speakers. My understanding is that a video of that memorial will be posted on the department's website. Emmanuel is a brilliant economist who many, including myself, consider the leading macroeconomist of his generation. He had broad interests and was remarkably insightful and creative. He made fundamental contributions to the theory of taxation, macroeconomics, and international finance. But instead of going over those contributions, I'd like to say a few words about my personal interactions with him and his students. I knew Emmanuel for years as a colleague, but we developed a much closer intellectual relationship over the past few months when we had been working on the macroeconomic impacts of the COVID-19 crisis and on the relationship between epidemiological measures and the macroeconomy. Our work together started in the second week of March on the last day that our office building, Litauer Center, was open. That afternoon, we were just about the only people remaining in the building, and we had a long conversation about the emerging twin crises. That conversation was socially distanced. I was standing in the hallway outside his office door. Because Emmanuel's work is highly theoretical, I had thought at first he might have little practical knowledge or interest in the situation and would view the COVID crisis academically, that our conversation would be brief, leaving us to collect our things. But that preconception was completely wrong. He was deeply worried about the twin crises and how they were already, in his view, being mismanaged. He was highly motivated to try to understand what measures could mitigate the twin crises, not simply set them out as a simplistic problem of jobs versus health. The undercurrent was how improving our understanding of the twin crises could in turn improve public policy. That conversation led to joint work on the crises, which we conducted with an epidemiologist at Harvard. When we started, I was worried mainly because I was intimidated by Emmanuel's brilliance. I'd always been somewhat intimidated by him. But he soon set me at ease. Yes, he was brilliant, but he was also patient in explaining his sectoral modeling and how it impacted our work. He was generous with his time, gentle in the way he put his ideas forward, and focused on making sure our work would usefully move forward the policy discussion, not just produce a paper with some academic contribution. Emmanuel was also committed to service to the profession and to the public. He was program chair for the World Congress. Since 2010, he served as a member of the French government's Council of Economic Advisors. During the COVID crisis, he also did non-academic work, helping policymakers make sense of what was happening in their economies. As Emmanuel's colleagues and students shared stories about him after his death, I realized that my experiences of his kindness, as well as his brilliance, were broadly shared. He cared about his students. He passionately wanted to make the world a better place. He was a constant source of ideas. He also cared deeply about our profession. Among other things, he hoped we could make our profession less competitive and more supportive. Emmanuel was a very special person, someone whom we can all aspire to be like. It is tragic beyond words that we have lost such a kind, creative, and brilliant friend and colleague.
Thank you very much. Thank you very much, Jim. So now it is my honor and my pleasure to announce that this year award has been jointly awarded to our 4 juniors, Elisa Rubo, Christian Wolf, Karin Kinnerud, and Martin de Reeder. We've been very impressed by their papers, by their presentation, also by their research agenda. And we are hoping to see a lot more from them in the coming years. So we hope that they will, keep high standards in research, strive to be relevant, keep curious minds, and also that they will promote collegiality and cooperation in the profession. So please join me in congratulating all of them for this very well-deserved award. Congratulations. It's hard on screen, I know, but we are with you. With this, the conference is now closing, unless any of the other organizers want to add a word. And there is also a link that has been sent around by Morten for us to for a post-presentation session in the chat. Thank you very much for all of you to have attended this conference. I learned a lot. I hope you also did learn a lot, and congratulations again for our juniors. Bye-bye.
Thank you very much.
Thank you.
We'll give people a minute to click on the link and then we will